Mike Vella, thank you very much for joining me today. How are you?
Very well, thank you. Very
Excellent.
nice to be here.
Thank you very much. I'm very excited about the conversations today, actually, because I think what you're doing and what Oxford Nanopore are doing with machine learning and AI is a genuine case study for AI being used for a positive good in the world. There's a lot of talk at the moment with, is AI good? Is AI bad? Where are we going? But I think how you're doing it and what you're using it for is genuinely something that's pushing society in a positive direction. So just before we go into it, just give a little bit of an introduction. You can tell me if I've got any of this wrong. But so previously, before your time at Oxford Nanopore, you were the head of solutions architecture of healthcare and life sciences at NVIDIA in Europe, Middle East and Africa.
That's right.
Now you are the senior director of machine learning at Oxford Nanopore, which is a UK-based technology company who are revolutionizing the way that scientists read DNA and RNA. You played a key role during COVID-19. You now work with hospitals, researchers, governments, and pharmaceutical companies worldwide, and are now one of the UK's leading genomic companies listed on the London Stock Exchange.
That's spot on.
Perfect.
Yeah.
There we go. It's a good start. So before we go into the tech and what Oxford Nanopore are doing, I'd just like to know a bit more about you and who Mike Vella is. So if you want to just tell us about your career journey and then what led up to you joining Oxford Nanopore.
Absolutely. Well, I'm actually a physicist by training. So ever since I can remember, ever since I was younger than my 7 and 8 year old sons are now, I was fascinated by two things: that's science and computers, really. So when I went to university, I studied physics, but I always maintained a sort of a love of computing and computer programming. Ever since I was probably 11 or 12 years old, my dad taught me to write computer programs, and then I had a really good computer science teacher at school. Was very fortunate. Was one of the few secondary schools that had computer science offered as a subject. So even when I started studying physics, I maintained an interest. I worked on open source projects, worked on little toy projects, and that led me to do a PhD in computational biology. So computational biology, quite surprisingly, I guess, is quite similar to physics. My PhD was on physical simulations of brain cells, of neurons, basically. And that was all using computers, using computer programming. Yeah, one thing led to another. That led me towards a sort of interest in machine learning and AI. Back then, no one really called it AI. It was much more called machine learning. And my career led me towards NVIDIA, and then finally Oxford Nanopore, where now I run the machine learning group, doing lots of interesting things, which I'm sure we'll talk about.
So what was it in particular about Oxford Nanopore, or like what led up to that being the company that you're at today? Was there anything in particular, or just right people, right place? How did that happen?
It's a combination of things.
Yeah.
I think a lot of people's careers are lucky coincidences, and I think mine really exemplifies that. But I joined Oxford Nanopore. When I joined Oxford Nanopore as the head of machine learning, and it was quite interesting because a lot of the stuff I'd done at NVIDIA was working with lots and lots of different companies, right? So as head of solutions architecture, my role there was to help different companies with their AI journey, with their machine learning journey. How do we use GPUs? How do we use machine learning to solve different problems? And a small number of companies that we worked with really stood out as technologically head and shoulders above the rest. And one of those was Oxford Nanopore. So it was a great. I felt like it was a great opportunity when they came and asked me, are you interested in leaving NVIDIA, doing something new? I leapt at the opportunity.
So you really helped them from the get-go already through NVIDIA when you were working there.
Yes,
and then
that's right. Yes, we worked when I was at NVIDIA. Worked with lots of different companies. My role there was really enabling companies in healthcare to accelerate their AI and machine learning journey, and Oxford Nanopore was one of those companies. It was a real flagship, actually. Yeah.
Do you think a lot of healthcare companies at the moment are really making the most of machine learning and AI, or is it just like the key few, Oxford Nanopore being one of them?
It's a mix. It's a real mix. Not everyone needs machine learning and AI to the same extent. I'm not one of these people who believes, if you're not using machine learning, you're doing something wrong. Far from it. companies that have a lot of data are companies that most benefit from machine learning and AI. And I think a few years ago, it wasn't the case that people were taking an active interest in this nearly to the extent that they could. But I think companies, I wouldn't say are making the most of it, but I do think everyone is now acutely aware that if they have a lot of data and they need to analyze that data, then machine learning is likely a big part of that story.
Which rolls massively into why you're using it at Oxford Nanopore, because when you're sequencing DNA, RNA, I'm assuming there's mass loads of data that you've got to go through. So before we go into how you're using AI and machine learning, what is it that Oxford Nanopore are really trying to achieve, and what problems are you solving? If you want to just give that high level overview of actually what it is you're doing.
So at Oxford Nanopore, we make DNA and RNA sequencing machines. So what is a DNA or RNA sequencer? As I'm sure everyone listening to this knows, every living thing has DNA or RNA. That's the instructions for coding proteins, which builds organisms. So once you've got this DNA, you've got a sample of this DNA. How do you work out what it actually is? Now, there's a few different ways of doing this. There's a few great technologies out there. Most companies that do this, most people who build this technology rely on essentially light, optical methods of detecting DNA, measuring what DNA and RNA is. We use a very different technique. So our technology measures essentially electrical properties of the DNA and RNA. I won't go into too much detail, but essentially we take a strand of DNA or RNA, we weave it through a tiny hole called a nanopore. That disrupts the flow of electrical current, and we can work out what that DNA or RNA is using machine learning. Our technology, you might say, well, there's lots of other, you said yourself, there's lots of other ways of measuring DNA and RNA. Why use your technology? Ours offers some really nice, unique benefits. You can get really long measurements of DNA and RNA. DNA and RNA is very long molecules, hundreds of millions of letters, characters, nucleotides. With our technology, you can have very long readouts of those DNA and RNA molecules. It's highly portable. So we have our technology has been deployed in all sorts of weird and wonderful places. The most impressive one to me and to most people is the International Space Station.
That's cool. Yeah.
The technology is very small. It's semiconductor based, so it's very portable, very robust. So it's most suited to those kind of applications. It's quite a lot cheaper than a lot of other techniques. So it's got some really nice benefits.
So if it's cheaper and you can do longer strains in a short amount of time, why wouldn't everyone just use that? Or is there benefits to both?
We are seeing massive adoption.
Yeah.
So I think there's a few different things at play. I think that other technologies have been on the market for longer. Yeah. So in that sense, any new technology, no matter how great it is, there's a period of there's a period where it's still being adopted. People didn't immediately from one day to the next switch to from VCR to DVD, or from DVD to streaming. So it does take time. Because the nature of reading DNA and RNA is so complex, so multifaceted, there are areas where we have like really amazing strengths, and there are areas where some of our competitors have some really have some strengths. So the answer is it's complicated, but I think primarily the reason that our technology is still, the uptake is huge, but I think primarily it's a question of time.
So in terms of how you're using machine learning for it, what does that process look like? Because obviously you're collecting a lot of electrical data and then trying to convert that into like an actual 3D sort of model of what you're looking at. Is that correct?
It's not a 3D model as such. So it's a sequence. It's a sequence of letters A, C, G, and T in the case of DNA. So that's all your DNA is lots of A, C, G, and T, like those four letters in combination. In computer science, we'd call that a string with a 2-bit alphabet. So machine learning has been central to our company for over a decade now. We used to use techniques like hidden Markov models, and now we've moved on to newer technology like deep learning, which isn't even that new anymore. Right, we've been using AI and ML for a really long time. So you asked the question, why do we use ML? How do we use ML? And the answer is we use ML across the board, perhaps the most important place where we use ML is that process of going from those electrical signals to those letters A, C, G, and T.
Yeah.
And this is actually really, really similar to automatic speech recognition.
Okay.
So
yeah.
it's almost basically the same technology, actually. So we're quite used to the idea now that you can speak to, you can speak to your phone, you can speak to a transcription service. I'm not going to say, hey, S word, because I think everyone's phone will go off. But we've completely taken it for granted now that works beautifully. It works really well. It wasn't the case until just a few years ago, right? And if you think about what happens when what happens with that technology. So I'm saying words right now. Mm-hmm. What am I doing with my mouth? I'm changing the air pressure in the room. That's basically all I'm doing. I'm changing the air pressure in the room. Your ears are picking it up, but your ears don't really care about how loud my voice is, my accent so much. What you really want to do is work out what's the sequence of words I'm saying. And for that, in deep learning and machine learning, we use a class of models called sequence-to-sequence models. And that's exactly the same thing as what we use when we go from electrical signals to DNA nucleotides. It's basically the same thing. So you've got a sequence of air pressure measurements, and you map that to a sequence of words. Or in our case, you've got a sequence of electrical signal measurements, and you map that to a sequence of DNA and RNA nucleotides. Literally the same thing.
Because those different letters, what is A, T, C, and G?
A, T, C, and G.
And they will just give off a different electrical signal based on...
Essentially,
okay.
Essentially. In the same way as if I say the word dog.
It knows what dog... what that sounds
like. You heard those sounds, and I don't say the word dog in exactly the same way because there's different people have different voices, but your brain can work that out, and a deep learning or machine learning model can work that out as well.
That's actually really interesting because I think a lot of time we think about AI, we think it's going to be this ridiculously complex solution to how it works, but actually it's a technology that we've used already, but just adapted it to a very specific use case.
Yeah.
So I think... Do you think people just try and overcomplicate it quite a lot when they think about AI?
No, I don't. I think I'm one of those people who likes making a distinction between AI and machine learning. Mm-hmm. Now, it's a blurry distinction, but I do think they are subtly different things. So to me, machine learning is taking a task where you've got to map one thing to another thing, right? And the example we've given is transcription. Someone says something, you record it, and you want to write out the text of what they've said. That's narrowly defined. It's replicating one facet of what a human could do. You could have a human sit down with a pen and paper and work that out. Yeah. In machine learning, you might do something else, like try and predict the stock market. So you've got some input. You've got some input data. You might have news reels streaming in, inputting, I don't know, TV, Twitter feeds, whatever, and stock prices, and you might try and predict the stock price in the next 5 minutes or whatever. Yeah. These are kind of constrained. All of those, to my mind, fall under the class of machine learning. AI, and where it does get really complicated, is broader than that. It's really simulating how a human behaves. So that's what, to me, perhaps behaves is the wrong word, how a human interacts with the world. So it's really simulating human behavior to great extent, or human conversation. And that is a lot more complex in many regards than what I've described, although they do use the same underlying technology.
So machine learning is really getting a large set of raw data, turning it into information that's understandable, probably quite a bit faster than a human being could do. Otherwise, we would just use a human to do it. In terms of your use
I don't know
case.
about faster. I mean, there's lots of reasons not to use a human to do something, right?
True.
So
you've got to manage them. They can only do it for a certain amount of time. There's lots,
some things are just boring. We don't want
true,
people doing boring things as much as possible, and repeatable, right? So machine learning. If you take a machine learning model and it produces an output for a given input. Yeah. Next time, it's going to produce the same output for that input. You've got absolutely no guarantee that a human will do that. So
it's that consistency, isn't it? Really,
it's consistency. Yeah.
So with this technology and being able to speed up the rate of sequencing DNA, what is like the large real-world impact that could have on medical science, really?
Yeah, it's massive. Right? So to some extent, every if we just focus on one thing, which is human beings and human disease, there's a whole world out there which I can talk about also, like things like plants. But if we just think about every single one of us has a genome, and our genome and the variants within that genome, the specific, if you took my DNA and your DNA, they'd be 99.9% identical. Humans in particular are a very similar species. You take two humans from anywhere in the world, they're going to have extremely similar DNA, more so than most animals by far. But those differences, those are the things that predispose you to benign things like what color your eyes are or how tall you are, but they also predispose you to things like heart disease. So every single one of us, every single person in the world, no matter how healthy, no matter how lucky they are, has a predisposition to some kind of some kind of thing that puts them at risk health-wise, right? So understanding that can modulate your behavior. It can help treat you. I think that as we go forward, we will begin to understand that a lot better. We will begin to understand how a person's genome, how the differences between their DNA and another person's DNA predispose them to certain diseases. We'll be able to treat disease a lot more effectively, understand things like predisposition to certain types of cancers or heart disease. I imagine a world where, you're sequenced as a baby. And then, and then maybe when you're 12 years old, a doctor can tell you, hey, there's this medication, which, you're fit, you're 12 years old, you're fit and healthy now, but if you take this medication, you're going to be at way lower risk of disease X when you're an old person. Or maybe, stay away from this kind of food, because for most people this kind of food is harmless, but for you it might not be the best. Or on the flip side, maybe I'm framing these things quite negatively. Maybe your genome will say, hey, like drinking wine is pretty bad. We don't recommend it for most people. But for whatever reason, we've worked out that your genome suggests that you're not particularly at risk. So enjoy
have as much wine as you like. Then
it's an interesting point. Like take that as an example. Now I'm not a doctor, far from it, but the UK recommends that you drink 14 units of alcohol a week. It doesn't recommend it. It recommends that you drink nothing, but as a maximum, you're recommended not to regularly exceed that. That's pretty coarse, right? For some reason, it's for some people, it's bound to be 8. For some people, it's probably 20. We don't have the ability to give those kind of fine-grained recommendations, but I think in the future, we will. And technology, looping back to our technology like ours, because it's portable, because you can deliver it at point of care, because it's cheap, will enable us to do that sequencing. And there's the other side of it, which is once we have huge amounts of longitudinal data, understanding people's genomes and how they relate to their health outcomes, we'll be able to do that predictive side as well, which is given what a person's genome looks like, what are they likely predisposed to, and what fine-grained recommendations can we give them?
So that's fascinating, because that's moving. At the moment, 2 people might go in to a doctor's surgery with a similar problem, but very different dispositions, and then the doctor will just prescribe the same thing because that's what they've been taught to do. But if we could sequence everyone from birth, for example, you might go, okay, you have the same illness as that person right now, but this drug is not going to be very effective against this sort of drug. So it's bringing a real, I think, bespoke medical.
That's what it's called, personalized medicine. That's just what it's called.
That's fantastic. And then also like your daily life. Someone might need more exercise than someone else. Someone might need more greens than someone else, for example. So it's really giving bespoke recommendations to everyone.
We're getting a bit far from machine learning here, but yes.
No, but I think that's where like this technology can lead to.
Yeah, I mean, the truth is, I guess most people won't exercise enough and will drink too much and smoke too much, regardless of what you tell them. But yeah, it's a very good point. And then, we've just described human, but there's huge application in things like agriculture. Where what particular crop should I plant in this particular field, given, I don't know, the pH of the soil or something. Right now, that technology is advancing, but I think it's still very much in its infancy. And technology like ours can really
help.
will really advance our ability to maximize things like agricultural yield, in my view.
So it just gives us a much better understanding of biology as a whole, really, whether that's plants, animals, human beings.
All data. It's all data. Biology is. What does machine learning enable us to do? It enables us to understand complex systems and how they behave.
Yeah.
What do you need for that? You need a huge amount of data, and we're in a business of enabling people to gather that genomic data.
Yeah, that's really cool. So what was it that you guys were doing during the pandemic? Because I've read a lot about where you guys have gone, and I wanted, just really interested to know what.
So
you were
our
doing there.
technology was heavily used during the pandemic. Globally, it was heavily used, and the reason for that was that the coronavirus mutated quite aggressively. I'm sure we all remember Omicron and all the different variants. And it was very important to understand how a pandemic is mutating for various reasons. One, by studying mutations. Some are benign, but they allow you to understand how a particular virus is spreading.
Yeah.
Another reason is that some variants are much more harmful or much less harmful than others, and so by understanding which variant is present in your population, to what extent, you can better offer treatment and be prepared. So it was used extremely extensively. I don't remember offhand how many of the coronavirus sequences that were sequenced were using our technology, but it was a very substantial proportion.
Because there's just so much data right on the edge, isn't there? Everywhere you go, there's hospitals testing people, and if they can test there with these simple handheld machines, I suppose, they can send data in from all over the country, all over the world.
It's quick, yeah.
Yeah.
It's fast. You don't need to send your data to a lab and wait for it to be processed. You can do it there and then on site. Yeah.
That's just crazy, isn't it? To be fair, because even you could start doing that even at the hospitals in third world countries. You can find out what these diseases are there and then, instead of sending in teams going back to the lab. Yeah, that's really impressive. So how long has it been since Oxford Nanopore have really started using machine learning? Was that part of the technology from the get-go?
That was part of the technology from day one. So we were using machine learning before it was cool.
Yeah, nice.
Yeah. So, the signals that our sequencer produces, the sensors, the measurements that our sequencer produces, are not easy to interpret.
Okay.
And so you can kind of do it by eye. You can look at a signal by eye and kind of work out what the underlying nucleotides are, but not very effectively. And even with our very earliest techniques, we were using things like hidden Markov models, kind of a relatively out of favor technique nowadays, but one which is still quite useful to understand. Even from just fairly instructive, if nothing else. Teaches you quite a lot about how these models work. Even then, they were vastly outperforming what humans could do. So since the early 2010s, we've been using machine learning.
And what sort of technology stack are you using for that? Who are you using? I'm sure everyone knows NVIDIA are a big player in the machine learning AI world. Are they using them?
We are, yeah. So our sequencers, we've got lots of different types of DNA sequencers, but we allow users to buy a machine, buy a sequencer and plug it into their own laptops.
Okay,
so they can use NVIDIA GPUs. They can even use CPU, although it's horrendously slow. I wouldn't really recommend it.
Okay.
We even support Apple GPUs, so Apple Silicon. That's something that my team has been working on quite extensively, and we've got pretty decent support for Apple Silicon GPUs as well. We also ship our larger sequencers come with onboard compute, so NVIDIA A100 and GV100 GPUs. So we are very NVIDIA heavy. We're sort of NVIDIA is definitely the hardware that we target most aggressively. Some people have also adapted our technology to run on AMD GPUs, though.
Okay, so it can be used on anything really, if you know.
It can. We would generally recommend, if you were doing anything heavy, we would generally recommend NVIDIA GPUs,
right, okay.
Because we've spent a lot of time optimizing our stack for NVIDIA.
Yeah, it works, so it kind of makes sense, doesn't it? What's the plans with the future of Oxford Nanopore? Are there new technologies that you're trying to that you can't even tell me about? I don't know if there's probably things that you can't even mention, but do we see an increase, or are you at a level where you don't think the technology can get much faster, better, or?
It's going to get so much better.
Right, okay, yeah.
Well, the one thing we will not do is
Mm-hmm.
slow down. So very consistently, year on year on year,
Mm-hmm.
There was a time when people thought, 10 years ago, there were people saying, does this even work? And now it's one of the most accurate ways of sequencing DNA and RNA in existence. Every year, we've consistently delivered increases in the accuracy of our technology, the speed of our technology. So on every single metric, we've been aggressively improving. And not only do we not anticipate slowing down, but we actually anticipate accelerating the rate of improvement.
And do you think that's because of the technology that's becoming available with the GPUs and the compute, or is it the work that you guys are doing internally and fine-tuning?
It's everything. Yeah. So advances in silicon manufacture, advances in better and better chips that people like NVIDIA are consistently delivering, allows us to run bigger machine learning models, which makes our technology more accurate. Internally, our chemistry teams continue to push the boat out on better chemistry, but better nanopores, better enzymes. Electronics-wise, we may continue to make advances in electronics, and in my group, on the machine learning group, better models, better ways of training those models, better ways of evaluating our data. Across the board, there is no aspect of our technology which does not improve year on year.
That's cool. So, because the whole thing about machine learning and AI is obviously that it learns itself and gets better over time, and it's training more. Are they all linked together? Like, is every machine learning from data pool and they're all getting better?
No, absolutely not. One thing you've got to be very aware of when you do something that that sequences DNA and RNA, this kind of data is not always. It depends what you're sequencing. But if you're sequencing human DNA, certainly this is very private data. You've got to be very careful about where the data goes. So once one of our machine learning models is deployed on a customer's device, it's not sending us information that we use for training our models or anything like that. Far from it. No,
because that's even more private than your email, your home address. That is you as an individual, isn't it? Really?
Yeah, I mean they're all private, but I certainly, I'm not. I'm an employee of Oxford Nanopore, but I'm also myself a private individual, and I wouldn't be too happy if my DNA sequence was leaked. So
So have you ever actually hands-on use it at work? Or are you more on the technological side?
I'm more on the technological side. I have once or twice dabbled and
given it a go
technology myself, but I very much work on the analysis side. Yeah.
So day to day as well, outside of the actual task of Oxford Nanopore, do you use AI applications yourself? Are you like ChatGPT, Gemini? What do you use? And
So like anyone else, I use ChatGPT
Everyone loves it
all the time. I don't think there's that many people who never use it nowadays. I basically use ChatGPT sometimes for simple things like given what's in my fridge, what should I cook today?
Yeah, nice.
So, and I think that's interesting. That's I could talk a lot about that. I think that's when you know that technology is useful and successful.
When you start using it in your personal
life. It starts slipping into your slipping seamlessly into your life, that's when because people, I think that's the real test, right? It's like when you buy a pair of shoes, you think, oh, I like these shoes, or I don't. 6 months later, are they the ones you reach for? Or do you just see them and think, now that's when you know that I maybe the analogy is perhaps a bit poor, but that's how you know it slipped into your life. So but I use ChatGPT all the time. Help styling emails, asking for advice sometimes about quite banal things. So that's like anyone, I guess. I'm also quite a geeky guy, so I've been working on a few personal machine learning projects that are just nothing to do with work.
Yeah. Anything you can share on those ones?
Yeah. I've been working on some. So I'm a big outside of science. I'm a big motorsports fan.
Okay. Yeah.
Yeah. So I've been working on a reinforcement learning based way of doing like a Formula One strategy.
Okay.
Yeah, so
Interesting.
strategy call. So basically,
Yeah.
In a Formula One races are quite interesting things
Yeah.
from a machine learning perspective. You've got 20 or so drivers out on track, and you're on specific tires. You want to know when do you come in to do a pit stop, and what tires should you go on to. Lots of things come into play there. Yeah. So if you pit, what are you going to come out into traffic or not? What's the weather looking like? Is it going to rain? Because you might not be on the best tires, but if you think it's going to rain in 3 laps, well, stay out on those slightly rubbish tires and then come in for wets rather than having to come in twice. The strategy gets quite complicated quite quickly, and so in my sort of as a hobby, it makes me feel. I feel a bit sad calling this a hobby, but it is.
It is interesting.
That's what it is. Yeah, as a hobby, I've built a little F1 like strategy, like a little little timing board simulator, and then use train the reinforcement learning model to optimize what strategy a particular driver should be on in order to either win the race or reduce their lap time. The strategy you choose actually depends on what you're trying to achieve. If you're Max Verstappen, your strategy is probably how do I win the race. If you're in a slightly slower car, I don't know, an Aston Martin or something, your strategy might be how do I get points. But,
interesting. Yeah. That is really interesting, because I think it's showing that we can start taking so much data in different areas and then bringing it together to actually make better informed decisions. Because if everyone in F1 started improvising and using this tool, and it did.
Oh,
work,
they do.
Yeah,
I should say people in F1 use these tools, and they're like 1,000 times. This is just a little toy hobby, like toy project, hobby of mine. Theirs are 1,000 times more sophisticated than anything I've developed.
Do you think most companies will go that way, because business decisions will just start to get made with these AI machine learning tools, or do you think there's still a lot of value in human beings making those decisions?
What I think is that what AI does is it automates a lot of human thinking.
Yeah.
I don't think it's a particularly sort of unique view, right? And that allows decision makers within companies to focus much more on the higher level stuff. It's no different to computer programming, really. If you take in the last say 70, 80 years of computer programming, there was a time when computer programming meant writing machine code.
Yeah.
Right. And then C came along, and people said, oh, this is fantastic. This is a high-level programming language. You don't need to worry about individual registers or anything like that. And so there were some people saying, well, computer programming is dead now because C's come along in 1970 or whatever it was. Obviously, computer programming wasn't dead. My belief is that what AI does is it makes, in some sense, it makes thinking more of a commodity.
Okay.
And so, yes, I do think AI is going to have is already actually having a much bigger role to play in business decision making.
Yeah.
But at least for the time being, it's very, very unlikely that it will replace decision making. The human intuition still has an edge.
I think where I see the most value coming from it at the moment, especially in the now, is that we can use it to do a lot of the boring menial tasks that might take up 80% of our time in the day. You can automate that, and then there's really that 20-80 rule, isn't it? 80% of your results will come from 20% of the input that you put in. So probably 20% of our days is producing 80% of the result, but we've still got to do all those other menial tasks just to keep it going. And I think if we can put these automation, AI, machine learning tools on that other 80% of the day, then we can focus on that 20% and get better output and more productivity.
Exactly. I mean, and a lot of the productivity is kind of like micro optimizations. How many times have you needed to reply to an email, and you know what you want to say, right? You know what you want to say in response to the email, but it's going to take you 20 minutes to craft it. You want to be polite. You want to make sure you don't miss any nuance. And so if you were to write down, this is a trick I do all the time. I should probably be careful what I say. Now everyone knows. Now everyone's who listens to this is going to know how I write emails. You get an email, and you can write down what you want to reply to it in sort of casual offhand language in about 2 minutes. But then it takes you actually, it's exactly like you said, your 80-20 example, but it takes you 10 minutes to write the whole email.
Yeah.
Because 20% of your time is what do I want to say, and the remaining 80% is making sure it's polite and well structured and you haven't missed anything. AI accelerates that massively. You know, there's been many times when I previously would have said, I'll reply to that later. I'll be this lunch in 2 minutes. I'll reply to that later. But now I can just say, ChatGPT, here's what I want to reply. Here's what I want to say in reply to this. Please tidy this up and make sure I haven't missed anything.
I do that all the time.
Yep.
Like, especially if I've got to write a report up for something, I'll know exactly what I want to talk about, what key points I want to hit on. But instead of thinking, right, how am I going to structure this? What order should it go in?
Yep.
You just brain dump it all in, and it'll be like, blah, 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 blah.
And I think it's fantastic. I mean, some people think it's cheating, but I think that's a very incorrect point of view. It's still you that's writing the email.
Yeah.
You've just enhanced your productivity.
I think, as long as you're not using it to think for you, that's really, if you decide, I've got to write a report, here's the information bank, give me something.
Well, it depends what you mean by think, right? I think my mental I've got a mental model that you've got a certain amount of thinking you can do in a given day. That's how like you've got a certain amount of cycles you can spend, and the more you can spend that on the relevant stuff, on the important stuff, and let an AI model do the stuff that it can do, the better. Why not?
Yeah, that's true. What for people who, a lot of people I speak to, and it actually blows my mind how common this conversation comes up. Actually, is they're like, oh, I only have the free version of ChatGPT and probably use it once a week to just ask a simple question.
I think that's nuts.
That blows my mind, doesn't it? And I'm telling people you need to use it as well.
I mean,
it's that rate of adoption, isn't it? They'll have to one day. They'll have to. I have the paid version through work, but I have my own personal version I pay for anyway. So the best to ask the slightly odd questions.
I can barely think of better spent $20.
Yeah, that's true.
That's what it is. Isn't it? $20. I think it is. Yeah,
or something like that.
$20.
You get so much out of it as well.
If a human being said, "I'll do all this stuff for you for $20 a month," you think, "Oh, this guy's nuts."
Yeah, he's making no money in there.
Yeah.
I could imagine as well, physicist from a young age. Do you like to break things, try things, and do you think that's a good mindset to go in with trying to learn AI? Would you say?
Is your question what is your question?
Sorry,
exactly?
So the best way to learn these tools, someone who might be in that position where they're not really trying AI, they're not really using it. They might ask it one sort of a question they could have just asked on Google anyway. Do you think there's a way that you should start trying to structure your learning, or do you just go in, break it, push it about?
I mean, are you speaking specifically with regard to using tools like ChatGPT and stuff like that? Yeah. Well, I think they're pretty intuitive to use, right? When I think about AI, because in my job I'm responsible for machine learning and AI at Oxford Nanopore. When I think about machine learning and AI, my mind doesn't jump to interacting with ChatGPT and what's the best way to do that. My mind thinks about how is this working under the hood, how do we train our own models, and so I'll answer a slightly different question to the one you asked. This is an amazing time to get into this technology because it can use it to help you learn how to use it in some that's a bit of a funny way of putting it, but with the amount of data that we're able to generate now as societies, and the way this technology is advancing, the accessibility of getting into machine learning just as a career or something like that is incredible right now. There's things like Kaggle competitions. There's also amazing online tutorials, and I think if you just like the example I gave of a Formula One engine. Yeah. Now that we also have LLMs like ChatGPT to teach us, if someone wants to get into really understanding under the hood how this technology works, I'd say pick a personal project, something that you find interesting. Yeah. Do lots of reading. Learn as much of the underlying technology, the underlying mathematics of machine learning, and it's an incredible time. It's never been the case that our it's never. I don't think it's ever been the case that anyone can learn as much as they can now.
That is true. It's so fast now. You can, I think the rate of innovation of things has gone up so fast because of AI.
Yep.
Now, like for example, the tool you were talking about of F1, if you wanted to build something similar 10, 15 years ago,
It would have been months of work.
yeah. Months of work.
Months. It's literally days instead of months now. And not just that, not just building things, but also understanding our ability to, you've got a personal teacher.
Yes.
If I studied physics at university, if I wanted to understand something, I had a book, and if I struggled with that chapter of the book, if there was something I'm missing, I'd find my lecturer in office hours and discuss it with them. And if they weren't able to explain it to me, well, at that point, maybe I'm just not smart enough, or maybe I just haven't got a good enough lecturer, but something's gone wrong, and I'm kind of stuck. But now, it's so easy to learn. I love learning.
Yeah.
Right. So it's so easy to learn in the sense that you are your own limiting factor. If you want to learn anything, and I think machine learning is a particularly good thing to learn, then AI really enables you, because you've got your own personal teacher on your phone anytime you want.
You can ask it. I like it when you can ask it a question and it'll come back with something a bit too technical, and you can go, I really don't understand this topic. Can you simplify even more?
Yeah.
And then it will instantly explain that. Because I can imagine, like at university, if you're sat in a lecture hall and it's just a bit too advanced, this lecture, you're like, I'm going to have to wait till the end and then ask the questions. Whereas now you can go, oh, actually, I don't really understand this.
Yep.
Simplify.
Yep. Education's just changed completely. Like, I don't know if I've got two sons, a 7 and an 8-year-old. I don't know if they'll go to university. Like I took it for granted that I would if I wanted to learn stuff. But will they? Maybe, probably, possibly. I don't know. Is it necessary in 10 years' time when you consider where LLMs are now? Who knows what education is going to look like then? But it's one of the most fascinating aspects of this technology.
So I think a good way to like round this off actually is something a bit more in the longer future, a bit more far-fetched. People at the moment are really worried about if they don't use AI, they're just going to fall behind. They're going to lose their jobs. It's going to be game over. How do you see the world going when everyone starts using AI? Is it going to be everyone's out of jobs, everyone's going to be struggling, or is there going to be some sort of shift? I know that's a very hard question that very few people have got.
What I will
give
say
it a
is,
stab.
Yeah, I don't have a crystal ball.
Yeah.
So I mean, the real answer is I haven't a clue. Predicting the future is really hard, right? But yeah. I'll have a stab. But I'm wrong with almost 99% certainty.
We all are, but it's fun to make predictions.
I would like to think that people are going to work a lot less in the future. That effective working day goes down to a few hours because human work goes down, becomes a lot more about intuition and gut, and sort of setting the direction of what a company or particular human endeavor should do. I know you get people saying, but what about plumbers and what about bricklayers and people like that? But, like robotics is advancing pretty quickly. So if we're really into the speculative world, I mean, then who knows where that kind of work is going as well. Yeah, what's the nature of work going to look like in the future if thinking becomes a commodity? I really don't know.
I think that...
It's a bit Aldous Huxley, isn't it?
That goes back to that point of that 80-20. If we can do most of our work in that 20% of the time, do we need to work that decided 9 to 5 hours anymore? Or can we just do more output with 2-3 hours a day and then go and actually just enjoy our lives a bit more? That could be.
Or maybe 0 hours a day. Maybe work changes completely. I don't know. But
work's not a thing anymore.
Like I say, I don't have a crystal ball. Who knows?
Brilliant. No, Mike, thank you very much for your time. It's been really great talking to you. Is there anywhere anyone can go to have a look, learn about Oxford Nanopore, maybe even see if there's ways they can get involved? Someone might be interested in this field. Yeah,
so we've got a great website, loads of videos on YouTube. We also do, if someone's an engineer, software engineer, anything like that, and want to learn more about their technology, there's videos of me and my colleagues speaking about how our technology works, and we also open source a lot of our technology. Okay. But also, hope I don't regret this, but if you're particularly interested in machine learning and how it pertains to biotech and genomic sequencing, then I'm on LinkedIn. I'm very LinkedIn and Twitter, and I'm very happy to have people reach out to me.
Brilliant.
Reach out to me there.
Top man.
So
Mike,
I hope not too many people listen to this.
you can have a flood of inbox now. No, thank you very much. Brilliant.
Really nice
Cheers.
speaking with you. Thank you very much.
Thank you.